frequent and infrequent chord progressions and how they differ in different styles. So we can get a good picture of the syntax at work in a particular style by simply looking at the kinds of chord progressions that often occur in this particular style, in some particular style. So, for instance, if we take a representative set of classical music, and then we just count how many times the 5 chord goes to every other chord, then we could say things like 83% of 5 chords go to 1 chords, while only 7% of 5 chords are followed by 4 chords. And then we can track how often 5 chords go really to any triad. So we could create a tiny little table like this, for instance, which shows how often 5 goes to each of these other chords. So how often 5 goes to 1, how often 5 goes to 2, how often 5 goes to 3, and so on. And we're going to keep this column blank because we're not so interested in repeated chords. 5 going to itself is just it's just 5. And we could then use this same layout to show how often every other triad moves to every other chord in some repertoire. So this table is going to show how often each triad, 1, 2, 3, 4, 5, 6, 7, moves to each other triad, 1, 2, 3, 4, 5, 6, 7. And it shows all the percentages. So, for instance, this cell will mean that 15% of 1 chords are followed by a 2 triad. 39% of 4 chords are followed by a 5 triad. That's what that cell means. And I link in the text where I get these data. So there are some differences with this kind of statistical approach. This kind of statistical approach does not arise from tendencies or preferences, like we prefer descending fifths in the global model, and that's part of the way that we came up with the global model. We don't do that here. We don't use tendencies or preferences. We just count what happens. What it doesn't do is capture generalities or qualities well. So we don't have like a progression versus holding. So we don't have these kind of qualitative differences. It does, however, capture specifics very well. It says exactly how many times 5 goes to 1, for instance. And then it can also help us quantify specific differences between styles, because we could do the same sort of thing for pop and rock music, for instance. We could come up with this table that shows how many times 1 chords move to every other chord and 2 chords move to every other chord in pop rock music. And we can use this to show some specific differences between pop and rock and classical syntax. So, for instance, certain progressions happen infrequently in classical music, but happen often in pop rock. So, 5 goes to 4, only 7% in classical music, but it goes to 4 28% of the time in pop and rock. We've got a really different relationship between 4 and 1 and 5 and 1 in classical. So 4 goes to 1 22% of the time, and then 5, a whopping 83% of the time, goes to 1. If we look down at pop rock, 4 goes to 1 more than 5 goes to 1. 4 goes to 1 61% of the time. So this is a flipped relationship between 4 and 5 and 1. And then certain chords are just used less in certain styles, and this table will help us see that. So notice how in classical music, things just don't go to the 3 chord very often. And even though in pop rock those numbers are still small, they're much bigger than in the classical style. So 3 is used more in pop rock. And then 7 is progressed to a reasonable amount of time in the classical data, but almost not at all. Very, very small numbers in the pop rock. And so you can then use these tables to write typical progressions, and you can also use them to throw in some spice with unexpected moments. So if we started with a series of expected triadic progressions, we could do 1 going to 4. That's a reasonably high number. 1 goes to 4 28% of the time. And then 4 goes to 5 39% of the time. So this is also a reasonably high number. So 1 4 5. It's an expected progression. But now let's add an unexpected moment. So we're on 5. Let's find a smallish number on the 5. Well, 5 goes to 6, 9% of the time. So we could throw in this unexpected moment by going 1, 4, 5, and then 6. And then we could end with some expected moves until we get back to the tonic. So how about let's go down to 2. 6 goes to 2, 30% of the time, pretty high. 2 goes to 5, 72%. That's also very high. So let's go to 5, and then 5 goes to 1, 83% of the time, and we end. And we end with a progression that sounds like this. 1, 4, 5, and then we have our unexpected moment to 6, and then expected 2, 5,